Section 6.2 of our text discusses one-to-one functions and inverses. So friendly reminder that last class we talked about functions and what it meant to be a function. So in section 6.1 we went over what a function was again. And a function, friendly reminder, each x has exactly one y value, right? The visual I use to help us imagine a function was a vending machine, right? So just keep that vending machine in the back of your head as I introduce some new concepts. So let's talk about what a one-to-one function is. A function is said to be one-to-one if each x has exactly one y value, right? So for example, the square root of x is a one-to-one function because each x has exactly one y value. Note, here we have a parabola. This is still a function, but it's not one-to-one because 2 and -2 both map to 4, right? So to be a function, each x each x has only one y value. To be a one-to-one function, each x value has exactly one y value, and the converse is true. Each y value has exactly one x value. So in order to tell if a function is one-to-one, if I have f of a1 equals f of a2, that implies that a1 and a2 are all equal. A function is onto if for every b in B, right, that is our range, right? A is our domain, B is our range in this example. There exists an element of A such that f of A equals B. So for example, this function is one-to-one, right? Each x has exactly one y value and each y has exactly one x. But it's not onto because nothing maps to C. This graph here is onto, which is also called surjective, just in case it comes up. But each x has exactly one y value, but each y value doesn't have exactly one x. So it's not one-to-one, but it is onto because everything in my range is hit. Something maps to it. A function is a bijection if it is both one-to-one and onto. Bijection meaning it has both. I like keeping these little visuals in mind. I think it's nice to sketch little pictures and also really visualize what our graphs are doing. It's really important, and that's why I'm bringing it up for like the millionth time. So before, in order to test if something was a function, we had a vertical line test. So if it passed the vertical line test, our equation, our graph was a function. Now we have the horizontal line test. And the horizontal line test is this. If I take each y value, right, because I also need to check that each y needs an x value and only one. If I use my vertical line test and it passes the vertical line test, I know I have a function. Then I can use the horizontal line test to see if a function is one-to-one. So here I have a linear equation. It's one-to-one. Here I have a parabola, right? We know it's a function because it passes the vertical line test, but it fails the horizontal line test, so it's not one-to-one. Let's look at some not functions, okay? First thing is if a horizontal line intersects the graph of a function. So there's not even a point if I don't already have a function to use the horizontal line test. So let's test if these functions are one-to-one. If I set f of a equal to f of b, then I get a equals b. So I have f of x equals negative 4x plus 12. I rewrote the whole thing. Why did I do that? I'm going to take f of a and set it equal to f of b. I spaced. So I have negative 4a plus 12 equals negative 4b plus 12. If I subtract 12 from both sides, I get negative 4a equals negative 4b. I divide both sides by negative 4. I get that a equals b. All right. F of x equals the square root of 25 minus x squared. So I'm going to have f of a equal to f of b So that means the square root of 25 minus a squared equals the square root of 25 minus b squared. I need to square both sides because squares undo square roots. So I get 25 minus a squared equals 25 minus b squared. I divide both sides by 25. I get negative a squared equals negative b squared. We divide both sides by negative 1. I get a squared equals b squared. If I take the square root of both sides, I get a equals plus or minus a equals plus or minus b. Is this 1 to 1? Well, let's kind of envision what this looks like. So this is a square root function. I think I might have done this one incorrectly in class, and so I apologize. So, right, here I have my function. It's shifted to the right. It's going to look something like this. When x is 0, y is 5. Oops. It looks like this, right? It's a square root function. Does this pass the vertical line test? Yes. Does this pass the horizontal line test? Yes. So this is 1 to 1. I know it was kind of confusing because, like, wait, we've got negative a and negative b, but it's okay, right? Because we could visualize that it does indeed pass the vertical and horizontal line test.